Good morning, class. Mr. Carver here. Today we're going to tackle two of the three items on our prohibited derivative list. Remember, products, quotients, and quantities other than x raised to a power are on the prohibited list. We're going to take care of the first two today. The product rule essentially says this: if you derive with respect to x the product of, say, f of x times g of x, the way this works is what you'll do is you'll derive one of them. So let's say I take f prime of x. I then multiply that by the second underived. I then want to add that to basically the reverse of this. So I will write the first one down, underived, and I will derive only the second equation. So it's f prime of x times g of x plus f of x times g prime of x. Now what you'll notice here is I've got multiplication and addition. So order makes absolutely no difference. Typically I prefer to just derive the first one with my first term and derive the second one with the second term. It keeps it a little bit more organized and allows you to follow your work. So here's an example of a problem. Let's say I've got y is equal to x squared plus 1. I'm going to multiply that by the cosine of x. I would also mention this. I think product rule is one of the easier rules to miss. So please try to be aware. If you were looking at this, this is the this is the product of the quantity x squared plus 1 and the cosine of x. So you must use the product rule on it. All right, here we go. So when I derive the first expression first. So that's x squared plus 1. If you recall, the 2 comes down to the front, times x. Take 1 away from the power, plus 1, which goes to 0. So that's the derivative of the first term, or f of x in this case. Multiply that then by the cosine of x. Remember, it's the derivative of the first times the second as is. And then I want to add that then to the reverse. So I've got x squared plus 1 times the derivative of the cosine, which is negative sine of x. All right, I'm not going to have you simplify. One thing I should point out here is if you're multiplying by the negative sine of x, that must be in parentheses, otherwise it looks like subtraction. It's not subtraction, right? It's x squared plus 1 times negative sine of x. All right, let's do another example. Now, one thing you'll notice here is that you've got problems that look an awful lot like the problems you did in previous sections. It's totally okay. You've got the option of deriving them, however you would like. For instance, in this case, I've got this power of t that I could distribute to the three terms in the blue portion, in which case I would then just have to derive them each individually. But since we're doing the product rule today, let's go ahead and keep these separate, and we'll use the product rule. All right, before I get there, let's rewrite this here just a little bit. I've got y is equal to, that's t to the third power second root times all of the second there. T squared plus 2t plus 4. And now let's derive. So I've got y prime is equal to the derivative of the first term here. Remember, power comes down to the front. T, I take 1 away from the power. That's going to be 1/2 times the second as is. That's t squared plus 2t plus 4. I then want to add that to the reverse. So I've got the first one as is. That's t to the 3/2. And now I'm going to derive the second one. T to the second becomes 2t to the first. 2t becomes just 2, right? Because that's t to the first up here. The 1 comes down to the front. I take 1 away from the power. That's 2t to the 0. And of course my 4 goes to 0. This then is the derivative of y. All right, and it really is as easy as that. One thing I would like to point out is if you have something like this, y is equal to 6t to the third, you might be thinking, well, that's a product. Why don't I use the product rule there? You can use the product rule there is the answer. So if you think of 6 as being my first term, t cubed being my second term, those two things being multiplied together, my y prime then is going to be equal to the derivative of 6, which is 0, times t cubed, plus then the reverse, 6 times 3t squared, which gives me a y prime of 18t to the second, which is probably what you would have done after we finished section 2.2. Remember, 6 is a constant, so it is the constant times the derivative of the term with an x or a t in it. Either way, you get back to the same thing. So if one of them is a constant, you technically don't need to use the product rule because the constant goes away for half of the product rule. All right, let's tackle the quotient rule. And the quotient rule looks something like this. If I derive with respect to x, and that again is a command, of f of x divided by g of x, what I get is this. Don't be intimidated. It's okay. All right. The way this works is you copy the bottom function. So in this case, it's g of x. You just bring it up to the top. You don't change the sign of the exponent or anything. You just copy it down. It's g of x then times the derivative of the numerator. So it's g of x times f prime of x. And then I want to subtract the top as is times the derivative of the bottom. That's g prime of x. And I put that all over the square of the denominator. Odd, I know, but that is, in fact, how you create the slope machine from a quotient. All right, let's work through a couple of examples. Let's do y is equal to x squared plus 2 all over 2x. All right, and again, old rules or other rules, all the other rules that we've learned so far, will be mixed in with these quotient rules. So if I derive, I've got y prime is equal to, all right, let's just bring the bottom up to the top. That's 2x times the derivative of the numerator. That's going to be 2x to the 0 plus 0, minus then the high, which is x squared plus 2. Remember, you want to put that in parentheses because it's a quantity, times the derivative of the bottom, which is just going to be 2x to the 0. And that will be all over 2x squared. All right. Now, if you'd like to clean that up, all we have to do is multiply this out. That's 4x squared. I'll distribute a negative 2, taking care of this and the 2. So that's negative 2x squared minus 4 all over 4x squared. Combine like terms, that's 2x squared minus 4 all over 4x squared. I can take a 2 out of the top. Gives me x squared minus 2 all over 4x squared. Cancel, cancel. My final answer is x squared minus 2 all over 2x squared. All right, so tonight I think I would like you just to work on the derivative aspect of this. Don't worry too much about simplifying. All right, one more thing I want to show you. There's a mnemonic device that might help you remember this. If you look at this rule right here for the quotient rule derivative, the mnemonic device goes something like this. Low d high minus high d low over the square of what's below. Let's try that again. It's low d high minus high d low over the square of what's below. So it rhymes, and it's kind of catchy. If you get them backwards, it doesn't really work. High d low minus low d high over the square of what's below. See, it doesn't sound right. So you know whether you're doing it right, because for the quotient rule, order does matter. You are subtracting. So g times f prime must come first. F times g prime must come second. All right, one more of these. Y is equal to the square root of x plus 7 all over x. All right, and again, remember from section 2.2, what you may have done before you knew the quotient rule was bring this x up to the top, distribute it, and do them all separately. You're certainly welcome to do that, but the quotient rule must be used at times when that's not practical or possible. All right, here we go. Y prime. Remember, it's low, d high, and x to the 1/2 derives to 1/2 x to the negative 1/2. 7 goes to 0, minus high, which is all at the top, times d low, all over x squared. All right, and for right now, we're not going to worry about simplification, so you just need to set it up. This is where you would stop right there. We will get into simplifications shortly, but for now, we're not there yet. All right, there are 6 trig derivatives that you must memorize. So if you're keeping track, keeping a memorization list, which I strongly advise, here they are. The first, when you derive with respect to x. Actually, let me change the notation here just a little bit. If I've got y is equal to the sine of x, y prime is equal to the cosine of x. That's the first one. The second, if your y is equal to the cosine of x, y prime is equal to the negative sine of x. Remember what I told you in class the other day. If the trig function starts with a c and an o, it has a negative derivative. Here's the third one. If my y is equal to the tangent of x, my y prime is equal to the secant squared of x. Number 4, if y is equal to the cotangent of x, y prime is equal to the negative cosecant squared of x. Odd, I know, which is why I'm having you memorize it. It's very difficult to figure out without just memorizing it. If y is equal to the secant of x, y prime is equal to the secant of x times the tangent of x. And the last one, if your y is equal to the cosecant of x, your y prime is equal to negative cosecant of x times the cotangent of x. All right. So get those down, put them on flashcards, say them to yourself before you go to sleep at night. Believe me, it aids with sleep. All right, here we go. Let's do a problem. How about y is equal to x squared times the secant of x? All right, and again, new rules will be mixed in with old rules. This is, in fact, a product. So my y prime is equal to the derivative of the first one times the second one. That is 2x times the secant of x. I want to add that then to the first underived times the derivative of the secant, which is the secant of x times the tangent of x. And that is your derivative. All right, let's say I've got y is equal to the cotangent of x over the cosecant of x. Hey, that's a quotient. Here we go. Y prime is equal to low, which is the cosecant of x times the derivative of the cotangent. Cotangent goes to negative cosecant squared of x, minus then the high, which is the cotangent of x, times the cosecant, which is negative cosecant of x times the cotangent of x, all over the cosecant of x squared. All right, keep in mind that when you're multiplying by a negative, put it in parentheses. Otherwise, it's going to look like a subtraction problem, and that will not be correct. All right, people, that's it. This is your slope machine. Slope machines work like they always have. If you're interested in knowing the slope of that original function there, at, say, x is equal to pi, all you do is put pi into the derivative wherever you see an x. And you will, in fact, my friends, get the slope of the original at that x value. Guys, take care. Good luck. Let me know if you have questions.